Let us remember, all positive numbers have two square roots. One is positive and the other one is negative. Let's have a short review. If we have 3 times 3 and we write that in exponential form, that is equal to 3 squared. This is also equal to 9. Now, if we have negative 3 times negative 3, that would be negative 3 squared in exponential form. And also, negative 3 times negative 3 is positive 9. That is why we have two answers in a given square root. Let's now proceed to square roots. In an algebraic notation, if our given is the square root of b, our answer will be a. 9, the answer is 3. And negative 3. Because negative 3 times negative 3 is equal to 9. There are two possible answers for the square root of 9. Again, the answer is positive and negative 3. So that is with an index of 2. So that will be 7 times 7 is equal to 7 squared. Let's rewrite the radical 7 squared, the square root of 7 squared, the index, and the exponent. So the answer now is 7. Our answer, very good, positive and negative 5. How about the square root of 81? Our answer, positive and negative 9. So again, the index here that is invisible is 2. So think of a number. When you multiply by itself, the answer is 144. We have 12 times 12. The answer is 144. So we now rewrite this as exponential 12 squared. So let's write the square root of 144 is the same with 12 squared. So the index here is 2. We cancel that. And the answer is 12. In rational exponents, we have the square root of 144 is also equal to 144 raised to 1 half. Correct? So if we are going to rewrite 144, we can also rewrite that as 12 squared times 1 half. And that is also equal to, as we cancel the exponents, 12 raised to 1, and the final answer is 12. Okay? Remember that if a is a positive number or a positive integer that is not a perfect square, then the square root of a is an irrational number. Example, the square root of 2. 2 is not a perfect square. Therefore, this is an irrational number. Okay? Because it is not a perfect square. How about square root of 10? Is also an irrational number. How about the square root of 5? Also an irrational number. How about the square root of 35? That is also an irrational number. Again, they are all irrational number since the integer is not a perfect square. Cube root. The cube root of b is denoted by this symbol, the cube root of b. And the answer to this is a. If and only if a is multiplied by itself 3 times. Let's find the cube root of 8. What is the number that when you multiply 3 times, the answer is 8? So, let's try 2 times 2 times 2. And as we write that in exponential form, that will be 2 raised to 3, and the answer is 8. So, if this is the case, we can rewrite this as the cube root of 2 cube. Okay? Since this is 3, the index is 3, and the exponent is 3, we can cancel it, and the answer now is 2. So, think of a number that when you multiply 3 times by itself, the answer is 64. 4 times 4 times 4. The answer is 4 cubed, which is equal to 4 times 4, 16, times 4 is 64. So, let's now use 4 cubed. Right? 4 cubed. And so, these are both 3, 4. Because the base here, the number that we multiplied 3 times is 4. Okay, let's have the last example. What will be the answer? That will be cube root of 10 cube. So, we cancel that and that. The answer is 10. Square root of 25 over 81. So, simply get the square root of the numerator, like square root of 25, and the square root of 81. So, that would be the square root of 25 is 5, and the square root of 81 is 9. So, our answer is positive and negative 5/9.